Unit 4, Lesson 2. Now we're going to get into some exponent rules or exponent laws that are going to help us to simplify things and not have to worry about expanding, and let us work with some algebra and exponents. So there's 5 basic exponent rules that we're going to use to simplify powers without actually having to calculate anything. First one is the multiplication rule. So I'm going to show you where it comes from, and then I'll show you the shortcut. So the multiplication rule, we should know that 3 to the exponent 4 means I'm multiplying 4 3's together. And then I'm multiplying that by 3 to the exponent 2, which means I'm multiplying 2 3's together. So all together, when I'm multiplying 1, 2, 3, 4, 5, 6 3's, which would mean I would have 3 to the exponent 6. So the question really is, how is 6 related to the 2 exponents I started with? And if you're pretty good with some simple arithmetic, you're going to notice relatively quickly that 4 plus 2 equals 6. So in general, whenever I multiply anything, any 2 or more powers together, I can add their exponents. There's one little thing you've got to watch for. In order to use this exponent rule, the bases always have to be the same. So an x and x, or a 3 and a 3, but the bases must be the same to use your exponent rule. And if you have the same base and you're multiplying, you can add your exponents for a shortcut. So that's the first exponent rule, the multiplication rule. The second exponent rule is the division rule. So it kind of makes sense. If there's a multiplication rule, there would be a division rule. And we know that for the exponent 5 means 4 times 4 times 4 times 4 times 4, 5 times. And we're dividing by 4 times 4, 4 squared, 2 times. And you should know by now, if you have a fraction and you have the same thing on the top as you do on the bottom, you can cross it out. Which means I'm left with only 1, 2, 3, 4's that I'm multiplying. And if I'm multiplying 3 4's together, that would be the same as 4 to the exponent 3. So the question is, how do these 2 exponents relate to the exponent of my answer? And if you're quick with some arithmetic, you would know that 5 take away 2 equals 3. So the division rule, in general, is when I'm dividing and I have the same base, I keep my base and I subtract my exponents. So when I'm dividing with the same base, I keep my base and I subtract my exponents. And I think we might go back and write that down on our multiplication rule. We'll write it out with words. So division rule, when you're dividing with the same base and powers, you keep your base and you subtract your exponents. Multiplication rule, when multiplying with the same base, keep the base and add the exponents. Keep the base and add the exponents. So it kind of makes sense. Multiplication and division are opposites of each other. Dividing is the opposite of multiplying. And when I use my multiplication rule for exponents, I add them. And when I use my division rule for exponents, I subtract. And adding and subtracting are opposites of each other. So multiplication rule, Division rule, keep the base, subtract the exponents. Third one is the power rule. So the power rule is when you have one base and two or more exponents with that base. But the important thing is that you notice there's only one base. When that happens, this is saying I have 3 to the exponent 2 to the exponent 3, which means I have 3 of whatever's in the bracket being multiplied. So I have 3 squared times 3 squared times 3 squared multiplied 3 times. And then you know that 3 squared would mean 3 times 3. So I have 3 times 3, and another 3 times 3, and another 3 times 3. So that all together I would have 1, 2, 3, 4, 5, 6 3's. That would be 3 to the exponent 6. And just like with the other ones, the real question is, how does that new exponent relate to the original 2? And if you're good with your number facts, you will know that 3 times 2 is 6. So in general, when I have 2 exponents or more and one base, I multiply my exponents together and I keep my base. So the power rule, when you have one base and 2 or more exponents, keep the base and multiply the exponents. So the 3 rules: multiplication rule, when you're multiplying powers with the same base, keep the base, add the exponents. Division rule, when you're dividing powers with the same base, keep the base and subtract the exponents. And the power rule, when you have one base and 2 or more exponents, keep the base and multiply your exponents together. Okay, so we're going to use those rules now. One comment in math: simplify versus evaluate. Simplify means that you use your exponent rules only, and then you quit once you're done using your exponent rules. Evaluate means use your exponent rules and then calculate an answer. So evaluate goes a little bit further than simplify. So evaluate means you're going to use your exponent rules and then calculate an answer. Simplify means use your exponent rules only. Often you'll see this instructions: simplify the following and then evaluate. That means you have to do both. Make sure you use your exponent rules and then get your answer. So when I'm going to decide about my exponent rules, I look at the question and I decide, is it multiplying, dividing, or one base? That will tell me which exponent rule to use. So when I look at question A and I see those brackets and the exponents, I know the brackets mean to multiply. So I know this is a multiplication question. Because it's a multiplication question, I'm going to use a multiplication rule. And the multiplication rule says to keep the base, which is 3, and add the exponents, 2 plus 5. So I'd have 3 to the exponent 7. So I just simplified using my exponent rules. Then it says I should evaluate where possible. So 3 to the exponent 7, I will type it in my calculator. 3, use the exponent key, 7, and get 2,187. So I've evaluated. I use my exponent rules, and then I evaluate it. So I look at question B, similar to A. All those brackets means that I am multiplying. So if it's a multiplication question, I'm going to use the multiplication rule. Multiplication rule says I keep the base of -4 and I add my exponents together. So I have an exponent of 2. I also have an exponent of 1 that we're too lazy to write down in math. If there's a base and there's no number written with it, we assume there's an exponent of 1 because there's one base there. And then don't forget to add the last exponent, 3. So 2 plus 1 plus 3. So I have -4 to the exponent 6. Because my exponent is even, I know my answer is going to be positive. Because I have an even number of negatives, I'm multiplying -4 6 times. Every 2 negatives, I get a positive answer. 2 negatives make a positive. So 6 is an even number, so I'm going to have a positive answer. And I'm going to calculate my answer. 4 to the exponent, -4 to the exponent 6 would be 4,096. So I use my exponent rule to simplify, and then I evaluate it. So when I look at the next one, I decide whether I'm multiplying or dividing, and I see right away it's dividing. So I'm going to use the division rule. Division rule says I keep the base and I subtract my exponents. So 7 take away 3 is 4. And then I can evaluate 5 to the exponent 4, which is 625. D, don't get confused by looking differently. That long line also means divide. So the division rule says I keep my base and I subtract my exponents. So 8 take away 5 is 3. And -2 to the exponent 3. 3 is an odd number. So I'm going to have a negative answer. So -8. All right, last couple examples. E, I notice there's one base and 2 exponents. So that means it's a power rule. I keep my base and I multiply my 2 exponents together. So I get 2 to the 6, and 2 to the 6 is 64. Fractions don't change anything. The same rules apply. It's the same fraction. And I have brackets, so it's a multiplication question. So I use my multiplication rule. I keep the base and I add my exponents. So I have 1/2 to the exponent 6. And like we talked about before, I'm going to do 1 to the 6 and 2 to the 6. So I have 1/64 as my answer. Sometimes it gets a little more tricky, and you have to do a couple of rules at once. So the first rule I'm going to do is the multiplication rule, and then I'll do the division rule, because there's 2 in the numerator that are being multiplied. So I keep my base, and I add my exponents, and I get 6. And then I still have 3/5, so now I do my division rule, keep my base, subtract my exponents, and I get 3 to the 1, which is just 3. All right, your job is to practice the exponent rules on page 360, number 1 to 3, and 5 and 9.